Hey y'all, here is part 2 of your Unit 2 review, starting with question number 9. We are using the quadratic formula to solve this equation. So what we need to do is remember the quadratic formula. Hopefully you know this. Quadratic formula says x equals negative b plus or minus square root of b squared minus 4ac, and that whole thing is divided by 2a. So we need to identify our a, b, and c. Our a is 3, b is negative 10, and c is 8. So we will plug those numbers into this formula. So the negative of b is positive 10 plus or minus square root of b squared. B is negative 10, and we square it, minus 4 times a is 3 times c is 8. And we divide this whole thing by 2 times a, which is 3. So as we work this out, we have 10 plus or minus the square root of 100 minus 4 times 3 is 12 times 8 is 96. We're dividing all of that by 6. So this is 10 plus or minus the square root of 4 all over 6. And the square root of 4 is 2. So that's 10 plus or minus 2 over 6. So 10 plus 2 over 6 is 12 over 6. So x equals 2. 10 minus 2 over 6 is 8 over 6. So x is reducing that fraction 4 over 3. And here are your two solutions. X equals 2 and x equals 4 over 3. Now, let's take a look at number 10. We have this polynomial given to us, and we're asking us a whole bunch of questions. We are looking at its degree, if it's even or odd. The left end points down, the right end points up. So that is an odd degree. So they're pointing opposite directions. The right end is pointing up, right end, so that is a positive leading coefficient. Okay, so in terms of our zeros, places where the graph crosses the x-axis, at A, at C, and at F, that is 3 distinct zeros at A, C, and F. Now, if we look at what type of zeros we do have some differences here. A hits the x-axis and bounces back. That is a tangent root. So that is a tangent bounce. So that is a double root. Same thing at F. This is a double root because it has the tangent bounce. Tangent meaning it only touches in one place. So that gives us 2 double zeros at A and at F. And then we have a 0 at C that goes clean through the x-axis. So this is a single root here. So 1 single root at C. And that means we actually have a total of 5 zeros. A double that counts as 2, a single that counts as 1, and another double that counts as 2. So that is 5 zeros. Now, looking for the y-intercept, where the graph crosses the y-axis, that y-intercept is here at point D, and f of 0 equals 9, the value of that y-intercept. Then it's asking us for those local extremes. Okay, relative extremes. So we're looking for the high peaks and the low peaks, okay, wherever they are. So we have a relative extreme at A. It's a high point in its general area. B is a low point that counts as a peak. Travel back up. E is a high peak. F is a low peak. So there are 4 extremes. There are 4 extremes. The local minimums are the bottoms. Local minimums are the bottoms. So B is a local minimum because it's lower than all of the other points near it. And F is also a local minimum because it's lower than all of its other points. So there are 2 local minimums, point B and point F. And then the local maximums, the points that are higher than anything else in their general area. And if we look at that, A is higher than the points on either side of it. A is a local max. And up here, E is also a local max. So there are 2 local max points at A and at E. So the degree of our polynomial is 5, counting the total number of roots. Our degree is 5. So we need to calculate the value of A in our polynomial form. Polynomial will be A times x minus a root times x minus a root, and so on. Okay, our factors. So we need to find those factors, and we can find those from the roots. Can find those from the roots. A is a root at x equals -5. So that means x plus 5 is a factor. And since that is a double root, it is squared. C is a single root at x equaling -2. So x plus 2 equaling 0 is a factor. And since it's a single, we do not change its power. And then there is a root at 1, 2, 3 at F. So that is a root at x equals 3. So x minus 3 is a factor that equaled 0. So y is equal to A times all of this. That x equals 3 is a double root, so its factor gets a square. Now, to find that value of A, we plug in our y-intercept. Our y-intercept is 0, 9. 0 goes in for x, 9 goes in for y. So each of these factors, we will plug in for the x, and we will work out our A value. So every one of those x's becomes a 0. Okay, every one of those x's becomes a 0. And as we work this out, that's a here, not 0. That's a in the front. That's 5 squared times 2 times negative 3 squared with an a in front. So 9 is equal to, it's 25 times 4, 25 times 2 is 50, times 9 is 450. So 9 is equal to 450 times A. Then we divide by 450. And our A value, reduce that, is 1 over 50. So our polynomial, y equals 1 over 50, and then use the x's. X plus 5 all squared times x plus 2 times x minus 3 in parentheses squared, and this is our factored form of this polynomial. We needed to use the 0, 9, the y-intercept, to calculate that a coefficient. From there, once we have a, we plug in the a and leave the x's and the y's. So let's look at number 11. We are finding all of the zeros, and we are going to write this polynomial as a product of linear factors, meaning we're going to find its zeros, we're going to find its factors. First thing we need to do here is graph this. So I'm using Desmos because it's what I can use on this tablet easily. So here is number 11, that top equation on the left, 2x to the third plus x squared minus 16x minus 15. And as we look at this, I'm going to look for those whole number zeros. I'm going to look for those zeros that are whole numbers. So -1 is a 0, that's a whole number. 3 is a 0, that's a whole number. This other 0 is not a whole number, so it's not going to be as easy to work with. But we do have x equals -1, and we do have x equals 3. So we know that x equals -1 is a root. So x plus 1 is a factor. We know that x equals 3 was a root. So x minus 3 is a factor. Okay, now there's a third factor, and we can find that using synthetic division. We can divide out these two roots. So to do synthetic division, set this up, across the top, put the coefficients. We have a 2, a 1, a -16, a -15. And let's work on this x plus 1 factor right now. Take the factor x plus 1, change the sign. And that's a -1 on the outside. So bring down the 2, multiply, -1 times 2 is -2, add -1, -1 times -1 is +1, add, we get -15, -1 times -15 is +15, which gives us 0. Now, that's the remainder, and we were expecting that 0 because we knew x minus 1 is x plus 1 is a factor. We already knew x plus 1 was a factor. Now, we'll do this again. Disregard the remainder because it divided out perfectly. Do that synthetic division again, this time with the x minus 3 factor. Change the sign on the factor. Again, divide out a +3. Bring down that first coefficient of 2. Multiply. 3 times 2 is 6. Add. That's a 5. 3 times 5 is 15. Add, that's a 0. That 0 is our remainder. We knew x equals 3 was a root, so we knew when we divided out x minus 3, we would get a 0 remainder. Now, there's no other whole number roots to divide out. 0 is the remainder. 5 is the constant. 2 is the x coefficient. So the answer to this division is 2x plus 5. That makes 2x plus 5 another factor here. Okay. Now, if we check our value of a, okay, if we check our value of a, our y-intercept, if we look at that on the graph, if we look at the y-intercept on the graph, that is 0, negative 15. So that y-intercept, 0, negative 15. If we plug in the 0 to each of those factors, we need to find what value of a gives us that negative 15. And when we plug in 0, we get 1 times negative 3 times it's a 0 plus 5. That already equals negative 15. So that tells us that our a value is 1. So that means that this factored form with a being 1 is correct. The problem wanted us to find all of the zeros. So we already had 2 of them. X equaling negative 1 and x equaling 3. When we take this final factor, 2x plus 5, set it equal to 0. 2x equals negative 5. So x equals negative 5 over 2. Sorry. And these are your 3 solutions. And we can confirm that on the graph, x equaling negative 5 over 2. We can look at this root here on the far left, and that is negative 2.5. Now, let's do the same thing for number 12. We are going to find its roots. We're going to find its roots, find its factors, calculate that a value. So, taking a look at number 12, it's the second equation here. Okay, we have 4 places where this graph crosses the x-axis. We have x equals negative 3. We have x equals negative 2, x equals 1, and x equals 5. So this is a 4th degree polynomial. X to the power of 4 is the highest power. Has 4 solutions. These are all whole numbers. These are all whole numbers. So we have already all of the solutions. We had x equals, I already forgot those, sorry, negative 3. Negative 3, negative 2, 1, and 5. All right, we had x equals negative 3. We had x equals negative 1. No, we didn't. X equals negative 2. there we go. X equals positive 1 and x equaling positive 5 as all of the solutions. These are all of the solutions from the graph. Now, to find our factors, f of x will equal a times, add the 3, x plus 3, add the 2, x plus 2, subtract the 1, x minus 1, subtract the 5, x minus 5. Okay. Now, to find that a, we need the y-intercept of the graph. So I'm going to go back to the graph. I'm going to look on where the graph crosses the y-axis, or where the x value is 0. That is 0, 30 for that y-intercept. Y-intercept is 0, 30. So 30 will equal a times 0 plus 3 times 0 plus 2 times 0 minus 1 times 0 minus 5. Plug in that 0 from the y-intercept everywhere that existed. Okay, so that gives us 30 equaling a times 3 times 2 is 6 times negative 1 is negative 6 times negative 5 is 30. Multiply all that out. 30 equals a times 3 times 2 times negative 1 times negative 5. So 30 equals a times 30. So our a value here is 1. So our function f of x is x plus 3 times x plus 2 times x minus 1 times x minus 5. If you are ever not sure if your factored form is correct, you can graph that factored form on the same screen as the non-factored form and see if they are the same. Now, let's go to number 13. This is a little bit different type of question. Okay. How many times is 4 a root? So what we want to do is use synthetic division as many times as it takes until the remainder is not equal to 0. Okay, so to do synthetic division, as many times as it takes, till we don't get a 0. So cross the top. We have 4th power, 3rd, 2nd, 1st, no power, so we're good here. 1, negative 13, 60, negative 112, 64. So if x equals 4 is a root, that factor was x minus 4. So we put a positive 4 on the outside. So bring down that first one, multiply, we get 4, add, we get negative 9, multiply, negative 36, add, we get 24, 4 times 24 is 96, add, we get negative 16, 4 times negative 16 is negative 64, which is 0. So that remainder of 0 tells us we have a root 1 time so far. Now, we're going to keep doing this, disregard the 0. We're going to keep doing this with that same 4 on the outside. till we don't get a remainder of 0. Bring down the 1, multiply, we get 4, add -5, multiply, -20, add, we get 4, multiply, we get 16, add, we get 0. So that 0 being the remainder tells us now we have a root 2 times. And we'll do this one more time. Do this another time, I should say. We don't know how many more we need. We'll do this one more time. Put that same 4 on the outside. Put that same 4 on the outside. Bring down the 1. Multiply, 4. Add, -1. Multiply, -4. Add, we get 0. Well, that means we have a remainder, or a root 3 times, because that remainder, again, was 0. Okay, and I'm going to squeeze this in another time and see if this works again. And put 4, bring down that 1, disregarding that remainder, of course. 4, multiply, we get 4. Add, we get 3. That's not a remainder of 0, so that does not go another time. Okay, so we have a root only 3 times, and we can write this polynomial. We know because of that synthetic division, working 3 times, x minus 4 to the power of 3 is a factor, and the last synthetic division that gave us a remainder of 0. Okay, so not this part. 0 is the remainder, -1 is the constant, 1 is the x. So that factor is x minus 1, and this is our polynomial. All right, 14, last one. We want to sketch this graph. So we are looking at graphing this in the calculator. Here's our graph. And here's what this looks like. Okay, here's what this looks like. If we look at our roots, we have a single root going down at -3. Really need this to catch up. We have a single root at -3. At -1. At -1, we have a double root because it has a tangent bounce. At -1, we have that tangent bounce here. We were going down at 3. And then we have another root over here at +4. And we were coming back up through at 4. So let's check out that y-intercept. Click on that y-axis. 0, -12 is that y-intercept. So that's going to be pretty far down here. -12 being that y-intercept. And we can sketch this graph. We went down through -3, curved back up, and we did a tangent bounce at -1, went through that y-intercept at -12, and came back up at 4. So with a single and a double and a single root, that is a degree of 4, and we already knew that because of that x to the 4th is the highest power. It has 4 total zeros. The y-intercept was 0, -12. All 4 zeros are real because they do touch the x-axis. There were 2 that were single zeros. There was 1 that was a double zero. none that were triple. So finding all the zeros, x equals -3, x equals -1, which was a double, and x equals 4, which was another single. So we can write this in factored form. We'll need to calculate that a value. So f of x would equal a times x plus 3 times x minus 1 squared because of the double times x minus 4. Now, to find that a, we plug in the y-intercept, which was 0, -12. So -12 will equal a times 0 plus 3 times 0 minus 1 all squared times 0 minus 4. So working this out, -12 is a times 3 times -1 squared, which is a +1, times -4. So -12 equals a times, that does multiply to -12. So a is 1. It may not always be, but here a equaled 1. So our factored form of our polynomial, with that a being 1, we don't have to write it down, x plus 3, x minus 1 all squared. And I need to squeeze this over for more room to write that last one. And it is x minus 4. So here is that final factored form. All right, y'all, that's it for this video, and that's a good thing because my tablet and my pen are dying. Good luck on your test.